All right, welcome back to Pre-Calculus. This is Chapter 8. We're talking about systems of equations. This starts off pretty tame. They give us some systems here, some equations, and then they give us the solution. And they say our job now is to test to see whether or not this actually works. Okay, so just a little bit of a thing while we're going on about this. In three equations, three-dimensional space, okay, we have x, y, and z. We talked a little bit about vectors, and this would be our k hat directly coming out of the board. This is coming out of the page to you. So this would be our I hat, this would be our j hat, okay, and our k hat's coming over here. So with lines here, okay, or planes, because you can represent this as both, okay, the problem is that there's three things that could happen. Okay, so in two dimensionals, right, if we have two equations, two unknowns, we can get an equation that intersects at one point. Well, that could happen in three dimensions. We could have, a line, a set of lines, or a set of planes that intersect in one point. That's fine. Okay, so that'll work. Okay, so we got 1 point. So we have one solution. Okay, it's a consistent system. Okay, and that's good. We could get in two dimensions. Okay, we can get two lines that are parallel to each other and don't mix. Okay, so this is what they call inconsistent. Okay, in three dimensions, okay, x, y with the z, we have some, excuse me, something called skew, which we have a line, we have another line, and then we have a line that doesn't intersect anything, it doesn't do anything, just kind of plays like that. So this is called skew. You have their solution. So none of the equations would be true. Okay, so this is an inconsistent system. It's, well, that's nice, is that we have three lines, they have nothing to do with each other. Okay, the other thing we can happen in two dimensions with lines is that you could get a line and then you can get pretty much another representation of that line that's exactly the same thing. That could happen in three dimensions as well. Okay, so we get a couple of three lines that happen to be the same line every time. Okay, so this is a consistent system because we will get some points of intersection, a lot of them. Okay, but this is called a dependent system. Okay, so those are pretty much your possibilities here. So you can have one solution. We get, the lines intersect at a point. We could have no solutions. Okay, they're skew. They're effectively perpendicular, parallel to each other. Or we can get a dependent system. We could have a lot of solutions. Okay, now it might be that one line could be skewed to this. That's okay, but two of them are going to have infinite solutions, but this line is not going to work. Okay, it'd still be an inconsistent system. That's just the way it works. So if two lines line up and have a solution, that's fine. But the third one doesn't, like, well, that's inconsistent. That doesn't have a solution because we are looking for points where all the points intersect. Okay, so that is what we have for three equations. Okay, so the strategy that we're going to use here, okay, well, for this problem, we're just going to type them in. But the strategy that we're going to use here is I'm going to see if I can eliminate, okay, remember there's different ways of solving linear equations. One of them is substitution, one of them is elimination. We're going to try to eliminate all the x's in my second and third equation, all the y's in my second and third equation, and all the z's out of the third equation. And I'll show you what that's going to look like because that's what we're after in order to solve these problems. We want to be somewhat efficient in doing this. This is not the only way to solve these problems. Okay, there are other ways to do this. Okay, and that's okay. So I'm going to go ahead and stop us here and actually pause this for a moment. Okay, welcome back. Okay, definitely demanded immediate attention here. So we have our 2x plus y plus 4z is equal to 24. Okay, sometimes they use x of 1, x of 2, x of 3 instead of x, y, and z. My z's are always hard to write. So I usually try to do x1, x2, x3, but it doesn't really matter which way you do this. Okay, some books like those x sub 1, x sub 2, x sub 3. Some books, your book, likes x, y, and z. Okay, it really is up to the person writing the book as to which format they're going to use. Okay, and we are given that 205 is a possible solution. So that means x is equal to 2, y is equal to 0, and z is equal to 5. But we're going to see whether or not this fits. Okay, so in our equation, so we have twice x is 2 plus 0 plus 4 times 5 for my z. What is this going to be? We have 4 plus 20. This indeed equals 24. Check, it equals 24. Okay. For the next problem, we're going to have 3 x's, so 3 times 2, plus 2 y's, y is 0, okay, plus 1 times 5, okay, 1z. What is this going to be? This is going to be 6 plus 0, it looks like plus 5. 6 and 5 do make 11. Look at that, the right-hand side says 11, so this one checks out, that one checks out. Okay, but we got to do all 3 of them. Okay, so we have 5 times 2 plus 3 times 0 plus 2 times 5. What does that turn out to be? So that's 5 times 2 is 10. Okay, and then on the other side, okay, this is also 2 times 5, so that's going to be 10. That equals 20. Look at that. That one checks out, so that would be just fine as a solution. Okay, so in this case, it is a solution. Okay, see about what we have here. Okay, I guess we have to check to see what the next thing is. And then they're just going to have us pretty much run through the same thing for the next set. Okay, so I'm not going to waste our time with that. I'll go ahead and stop the video and we'll start with a new one next section. Okay, but this is an important technique to be able to do. It's like, did I get the right answer? Like, I don't know. Let's plug them back in and see. So this is something you will be doing. Okay, it's just not a very interesting thing what we're doing. Okay, so thank you for tuning in, and I will see you in the next video.